A warm welcome from me. Welcome to the TUM Campus Heilbronn, Stanford University, Stanford Digital Economy Lab webinar on a very fascinating and interesting topic, unrevealing future skills in the age of automation and AI, expectations and training. And I thank you for coming along. My name is Helmut Kretschmer. I'm the founding dean and also moderator for this interesting session. A few house rules before we start. The webinar will be recorded and posted online later on. That's how we agreed with the two presenters, and I hope you can agree to that too. Please mute yourself. That's typical for webinar structure, but if you want to have questions and hopefully answers, the chat function is open for you to use, and we'll try to observe what we see there as input. Today's webinar is starting by the observation that automation and artificial intelligence are changing the nature of work. The new use of these technologies has a very strong impact, that not just on work as we do it, but also on the skill demands that we can see in a variety of professions. To keep in line with these demanding possibilities and the new technologies, workers will require additional training, additional options to learn new things, to expand their career skills and also acquire the new knowledge. That only is not just driven by technological digital expertise, but also makes it necessary to acquire new cognitive, social, and emotional skills, coming to grips with what was so nicely called in yesterday's newspaper, the new additive technologies. But what are workers' perspectives and beliefs? How do workers perceive the risk their occupations are faced with and their occupation's automatability? Are they willing to participate in further training even more, such as skill enhancement programs? And what is the value of early career skills if so many things can change? It's interesting to me because in 2020, the Münchner Kreis, a think tank organization in Germany, published, actually under my guidance, a study on these topics. It was started as a deep dive into the relationship between AI and work. Of course, it changed over time because we realized, or better, we were forced to realize, that work and education are tightly interrelated. And we soon realized that life is also intertwined with working and learning. So actually, the study was then called Life, Work, Education 2035 Plus. I'm happy about the 35 plus. And in the insights, changes driven by AI in key areas of life. Actually, it's an interesting observation to look back already 4 years to the 51 different observations that the Stelfe study brought up. And if you are interested in reading that later on and finding out what our two presenters have to add to the open questions that we posed in 2020, I think Bettina will post a link to that study in the chat so you can download it. It's available in German and English. But without further ado, I would like now come to the two presenters that we'll have in this joint webinar between TUM Campus in Heilbronn and Stanford University's Digital Economy Lab. The first there will be two presentations. One will be on the value of early career skills, and the other one will be on the automatability of occupations, workers' labor market expectations, and willingness to train. I would like to thank the organizers in TUM Campus Heilbronn, Bettina Berscheid and Theresa Schick, for putting together the webinar, making sure that we find an appointment time, and of course to the Dieter Schwarz Foundation for supporting and strengthening the collaboration between TUM Campus Heilbronn and Stanford. In our first talk, we will focus on the issue's value of early career skills. And I'm happy that Dr. Christina Lange, she is a postdoc at the Stanford Digital Economy Lab, together with Eric Brynjolfsson, has agreed to give us a presentation. She has been on the Stanford Career Education panel on AI, Your Career and the World of Work. She has presented that paper at various other foundational works and has been an honorary research fellow at UCL School of Management, received the Roman Herzog Research Award for first prize for her dissertation, and of course the Katholische Universität Eichstätt-Ingolstadt's Best Dissertation Award. Many honors that she has put together. But the real interesting thing that I'll find you will see is that she has looked at not classic cognitive skills work part of marketing internet professionals, but has looked at the level of apprenticeships in Germany. And I think that is a very valuable contribution to look at 13,000 different skills that have been coded in that work and check whether they are influenced using artificial intelligence technologies, giving us real practical insight on what can do without further job. So without further ado, please welcome Christina Lange, and I'll ask you, Christina, to take over the screen and present your slides. Thanks for your attention.
So you should see my presentation now. Thanks so much for the kind introduction again. And yes, I want to present my paper today, The Value of Early Career Skills, which is joint work with Simon Wiederhold. In this paper, we actually measure which skills are taught through the German apprenticeship system and how they pay off on the labor market. So why is this interesting? So we all know that individual skills are important for their success on the labor market, both in terms of their employment prospects and also in terms of their wages. However, it's really, really hard to measure these skills in an objective way, and in particular, these early career skills that people learn when they're pretty young, immediately after they've entered the labor market, for example. However, it's also really important to develop a deeper understanding for these skills because, as Professor Kretschmer has already mentioned, there are a lot of new technologies that are emerging at the moment and that attacking us from different angles. So it's really important to understand these skills deeper to also determine how susceptible we actually are to technological change and which skills are complements to these new technologies and that we can actually leverage to have better career prospects. So it's really important to understand the career patterns of individuals and also the occupational choices of these individuals. Again, there's a lack of suitable data on worker skills that are actually relevant on the labor market. And here I want to mention what most of the literature is doing nowadays. The literature mostly uses years of schooling, for example, and also skill assessment tests, which are generally also really interesting, but they provide only a crude approximation of an individual's actual range of labor market relevant skills. And what I mean by that is there are some drawbacks to using these data in the context that I'm proposing, because they usually just test really specific skills. For example, the PIAC data, they test numeracy skills, literacy skills, and also ICT skills, so information and communication technology skills, but they miss like all of the other skills that are actually relevant on the workplace. Another thing is that these skill assessment tests, they also have their own range. So for example, on some tests, you can score 500 points. On other tests, you can score 200 points, whatever. So to make these comparable, economists actually transfer them to standard deviations. And a one standard deviation increase is really unintuitive to interpret. So this is no natural unit of measurement. And we also contribute to that in this paper. Because what we do, we use a novel data source to measure early career skills by using text data from standardized apprenticeship plans in Germany. And we use these plans to construct new skill measures of skills that are actually relevant on the labor market, comprehensive, and really detailed. The German setting is unique for doing that because the same skills are actually taught in an apprenticeship throughout Germany. So for the same occupations, one apprenticeship plan is valid, and this plan is relevant no matter whether you're doing your apprenticeship in the north of Germany or in the south. And these apprenticeship plans also specify the exact duration apprentices learn a specific skill, which brings me back to the previous slide. So we don't have to measure skill increases in standard deviations. We have a really intuitive measure of if someone has learned, for example, one additional month of cognitive skills during his or her apprenticeship training, this corresponds to X% higher wages. Another novelty is that we can also see in which part of the apprenticeship a skill is supposed to be learned. Is it in the second half or is it in the first half? In the first half, mostly the general skills are taught, and in the second half, the focus groups are coming in. So you learn the really specific skills, so we can also disentangle the value of general versus specific skill groups. Of course, to measure returns to skills, we need to link some sort of outcome data. We have to observe wages. So we link our occupational skill intensities to administrative labor market records to investigate these returns to skills over time and also over workers' careers. We're worried about selection because, of course, it's not random which occupation you're choosing. So we're always controlling for rich set of worker and apprenticeship establishment characteristics, including apprenticeship fields. And we're also conducting a lot of robustness checks in the paper to make sure that our estimates are also valid. In addition, we also leverage complementary survey data from PIAC and establishment information to control even more rigorously for selection into apprenticeships. Just a little preview. So we find that these complementary skills to new technologies like cognitive and social skills really pay off on the labor market, and also digital skills have really high labor market returns, but I'll come to that in more detail later in the talk. I assume not all of you are as familiar with the institutional setting of the German apprenticeship system as I am. So I want to give you some information on why this is a really special setting to study skills and returns to skills in general. In Germany, about 60% of workers have completed an apprenticeship, which means we derive skill measures for a highly relevant part of the workforce, not only for a specific subgroup. These apprenticeships, so how they work is usually you've completed lower or intermediate secondary school, and then you start your apprenticeship directly after. So you're between 16 and 18 years old when you start your apprenticeship. This makes us really confident to say that we derive the value of early career skills, because again, these students are really young. These apprentices are really young when they start their apprenticeship. So it's a valid assumption to say that they have not acquired human capital elsewhere. In Germany, we have a dual system, which means that these apprenticeships combine on-the-job training in firms and also education at public vocational schools. And it's divided in the sense that 3 to 4 days per week you spend at the firm, you work there, and 1 to 2 days per week you are in these public vocational schools. This is a unique institutional setting for deriving skill measures, also because the requirements and the skills of apprenticeship training, they're stated in the state-approved apprenticeship plans that are standardized across Germany by the so-called Vocational Training Act. And you might think, yeah, but firms can still teach some stuff in addition, or how can you make sure that they really stick to these plans? We can say so because there are uniform examination formalities, meaning that in each occupation, all of the apprentices in an occupation throughout Germany have to take the same exam on the same day. So if firms will only train firm-specific skills, their apprentices wouldn't pass the standardized exam. So this special setting allows us to identify the actual early career skills of, again, a large part of the German labor force. Let's dig into the data that we're using and that we're actually self-collecting in this project. These apprenticeship plans, again, contain the skills that these apprentices are required to learn in their apprenticeship. And in this project, we have hand-coded the skills of 165 apprenticeship occupations, with which we cover the largest part of the German workforce. Each plan corresponds to one apprenticeship occupation, and it states the occupational skill content in quite a large amount of detail, because on average, each plan has stated 120 skills. In addition, we can observe the exact number of weeks a specific skill has to be learned, and we also observe a proxy for the difficulty level, and I'll show this to you on the next slide. So in total, we have classified, as Professor Kretschmer has already mentioned, over 13,000 different skills in this project. A more hands-on description of what we've done. So you can see this here. This is an example for a translated apprenticeship plan. And what's important for us is, column number 3. I'm not sure if you can see my cursor, but I'll show you what I'm talking about with my cursor. So column number 3 is of interest for us. We say each bullet point corresponds to one specific skill. So if we say 13,500 skills, this means we have taken a look at 13,000 different bullet points and we've assigned a skill label to it. For example, analyze process flows in bullet point C would have gotten a cognitive label because analyzing things is a critical and analytical thinking, which we deem as a cognitive skill. Column number 4 is divided into 2 columns. Here you can see month 1 to 15 and month 16 to 36, which is the first half and the second half of a 3-year apprenticeship. So we can observe that all of these 6 skills are supposed to be learned in the second half. So we would consider them specialized skills. And here you can see that these skills are supposed to be learned for 16 weeks. And since we cannot see if there's like a distinction in terms of importance with the skills, we just assume equal weight. So we divide the 16 through the 6 bullet points, and this is how we assign our skill weight. Because it's really difficult to run regression with like 13,500 skills and maybe also not that meaningful because these skills are like so different across all of the occupations. We've grouped them to have a more similar classification throughout the occupations into these 5 skills. So we distinguish between cognitive, social, digital, manual, and administrative skills. And we do so because, the literature deems these or says that these are the most important determinants of employment prospects and wages. And here I'm talking about cognitive, social, and digital skills. Here you can see some descriptives on our hand-labeled plans. On average, the apprenticeships are like 3 years long. There are some that are shorter, some that are longer. Again, on average, we have 120 skills per plan. And here you can see last update, because this is also another feature that I haven't mentioned before. These apprenticeship plans also get updated from time to time. In this project, we only use the most current version of the plan, but I'm talking about how to extend the project in just a second. Here you can see the skill shares of our apprenticeship skills. You can see that most of the apprenticeships have a high amount of cognitive skills that you're teaching, followed by manual skills. The third largest group is administrative skills, and social and digital are only like a really minor part of apprenticeship training. And this is especially for digital skills that are in really high demand. And we will also show later that they really pay off on the labor market. But the German apprenticeship system only teaches them to a really minor extent of only 2 months on average. We were talking about AI and how AI actually changes the world of work, but AI actually also changes how we work as researchers because we can leverage these new technologies to be more productive and to also extend the scope of our work, which is what we're doing in this project. I've mentioned that we have hand-coded the most current version of apprenticeship plans, which was really tedious and also took a lot of time. So in an extension of the project, we now went back to the 1970s, and we have actually coded all of the updates and all of the apprenticeship plans that have been in place since the 1970s. And we used a Gen AI model to label the skills. So what we've done by hand previously, now an AI model can do for us, which is really, really helpful to extend the scope of our work and helped us to go back in time and really increase the data set that we're using. And I'm hoping to present some new results on that soon. In this paper, we also conduct several validation exercises to show that our measures are valid, which I'll skip here in the interest of time. And I'll go directly to the link with the administrative labor market data. We are linking our data to the sample of integrated labor market biographies, or ZIAB in short, which is administrative data covering a 2% random sample of the German workforce, so all of the workers that are subject to social security records and a 2% random sample of that. In our analysis, we take the 1990s to 2017, and the ZIAP provides workers' full employment histories, including the apprenticeship occupation, which is most important for us in that context. It also contains information on wages. We have basic demographic characteristics to control for or to use in our regression, and also establishment characteristics. We only use full-time workers whom we can follow for more than 15 years after labor market entry to avoid a selected sample. And then we link our skill data to labor market data at the level of the apprenticeship occupation, which is at the 5-digit level. This is our empirical specification. Y is our outcome of interest, which in the table that I'm going to show you will be wages, but we also do that, for example, for occupational switching. We also do that for on-the-job training. And we also do that, for example, to check whether people who have learned more digital skills also tend to go to university more often. We always use all of the skills as a vector to also account for correlations between the skills. We control for worker characteristics, apprenticeship characteristics, and our standard errors are clustered at the occupational level. The fact that we're not using any quasi-experimental variation precludes a causal interpretation of beta 1, but we always make sure to control for the most daunting confounds, and I'll also show you some robustness checks in addition. In the future, we will be able to leverage within occupational variation through the updates, and this will also give us the opportunity to estimate more causal returns to skills. This is our main results table. Here you can see the returns to skills following workers over their careers. So if someone has learned one additional month of cognitive skills, 16 to 20 years after labor market entry, this is associated with 1.3% higher wages for cognitive skills, 1.5% higher wages for social skills, and even 2.1% higher wages for digital skills. We have benchmarked this with the returns to 1 year of schooling by just running the classic Mince wage regression. And here we find that the returns to one additional year of schooling would be 7.9%. And this shows that our returns to skills estimates are also economically meaningful in size. We can distinguish between these general and specific skills, and this is also important in the context of technological change, because there's this hypothesis out there that having a really specific training, which an apprenticeship is, makes you more susceptible to technological change because you're less flexible. So we were really interested in which part of the skill actually drives our wage returns. Is it the general skills that are taught in the first half of the apprenticeship, or are those like the specialized skills? And we actually see that the general skills are indeed the ones that seem to drive the returns to wages, which is interesting with regard to the hypothesis of susceptibility to technological change that I've just mentioned. And this is also a pretty novel result. We conduct several robustness checks. We also check whether the returns to skills are different for small and big firms, and whether there are differences by gender, meaning that some skills pay off more for women than for men. We actually find that women have higher returns to cognitive and social skills than men, but lower returns to digital skills. So this is also a really interesting aspect that we want to evaluate deeper. One last thing that I'd like to show you is the returns over time, because also the returns to skills are changing over time in general, meaning that, for example, here digital skills became more valuable in the 1990s when the office computer was introduced. And so it really took off in the 1990s, and it increased ever since. And here we also see that the returns to cognitive skills have steadily increased, even if it's more modest, followed by the returns to social skills. So we can basically also replicate the findings that are valid in a high-skilled professional context that have been shown by Deming and Kahn, but we're actually, we can show that for a low and middle-skilled context in the German apprenticeship setting. Just to wrap up, so we derive a detailed and comprehensive classification of workers' early career skills, a novel skill measure based on these apprenticeship curricula in the German context. We also see that apprenticeships, providing higher cognitive or social skills are associated with higher wages in the short and in the longer run, while digital skills seem to pay off later in life. Yeah, we see these increasing trends in the labor market returns to cognitive, social, and digital skills over the last 3 decades. And what are open policy questions for us are, for example, are these apprenticeship plan modernizations fast enough to keep pace with the changing skill needs of employers in the face of like recent technological advances like generative artificial intelligence? So thanks so much for your attention, and I'm looking forward to the discussion.
Christina, thanks a lot for this fascinating presentation and really detailed insight into the effects of early learning, whether it's obviously in apprenticeships or in any other interesting role. But I think it makes very obvious that it's an important part to observe. If the difference is that large or the effect that large for such a small amount of time spent on learning compared to the overall time of learning, it's an insight that over the last years, the digital area really has grown in importance. You have a 15-year back characteristic. So if you remember 15 years back, some of the technologies we use today as normal have not been implemented or might be invented, but not really brought to fruition. Thanks a lot for that really detailed insight and also to give us concrete examples on where it makes a difference. And I'm sorry we can't go into all the details that you have kind of shown already on your slides. With that, and in the area of looking at the chat, I see no further questions coming up immediately. So I'll ask everybody who's in this webinar to, if you have questions, don't be shy. You don't have to speak up. You just have to type up to pose a question, and I can certainly take the opportunity to read it out to everybody. And there is the first question, which I would like to give to Christina, so you have at least one, and that is, I think, pretty general. How might AI change KPI measurements for companies and organizations? You already shared a concern whether the skill descriptions in this apprenticeship charts are too static. I do know that in some of the German discussions, they are deemed as being too static. So how do you see the even forthcoming changes in the key performance indicators that we use for companies and organizations?
Yeah, I mean, one thing that we always talk about at the Digital Economy Lab is also, of course, productivity as like a performance indicator for firms. And what's really hard to understand, because with AI, there's a lot of research showing that you can actually perform the same tasks faster, you can perform more of the same tasks in the same amount of time. And yeah, so this means you can create more output with less input, and this will increase productivity, yeah, in the short and in the long run. Even if in theory you put like less work into it, if the output is higher, then this will increase productivity. And I think this also, deals with the skills that we actually need to deal with these new technologies. Because first you have to teach the workers first which tasks, for example, do you do in your daily work, and then how can you use AI to do these tasks faster? Because how should they know how to actually incorporate that into their daily life? And it also relates to the skill needs that Professor Kretschmer has mentioned. You have to equip them with the skills to use these technologies.
So I think it's, of course, a conversation in Eric Brynjolfsson's lab to talk about productivity and the outcomes of having skills and using skills. And that gives me the opportunity to, without further ado, go to our second presenter. Because we think that the skills that you have actually have an impact. But the question is that is often debated, is there an automatability of occupations We do know from the various studies that are around since 2015, 2017, that it's probably not the automobility of an occupation as such, but about specific tasks, specific skills that might be impacted a lot. And that then leaves us into this complicated area of how is it if you look at occupations, the workers' labor market expectations and the willingness to train. And then I'm happy that we have Professor Philipp Lergetpoer with us. He's at the TUM Campus Heilbronn, the residential economist, I would say. He's an empirical economist, like we have already seen, empirical work who conducts policy relevant research at the intersection of education, economics, public economics, and behavioral um, economics. I think that pursues many of the interesting areas if you look at the effects of artificial intelligence. He finished his PhD in economics in Innsbruck, then was a postdoctoral researcher at the IFO Center for the Economics of Education in Munich. He was also a visiting scholar in Chicago or at Stanford. That's where he could have met, which would be exactly there at the same time, and in Bergen. And since 2021, he's at the TUM School of Management, Campus Heilbronn, in the Global Center for Family Enterprise. Without further ado, Philip, please go ahead.
Helmut, thank you very much also from my side, and thanks for having me as part of this wonderful event. I will share my screen now as well, so that you all see my presentation. So can you all see my presentation? I assume this is the case. Perfect. Okay, so I'm switching focus a bit here because we are mostly interested in this specific project about skill acquisition, but not as early as an apprenticeship, but later in life. So we will talk about on-the-job training and whether people are properly informed about what skills they will need, or whether they will need to engage in further training to keep up with the pace of the automation that we see around the globe. The paper that is behind this project or this presentation is called Automatability of Occupations and Workers' Labor Market Expectations. So what is the motivation for the study? The motivation is that mega trends, we have mentioned digitalization, but also other trends like geopolitical developments, demographic change, transform the economy and labor markets. And for digital technologies, we've seen a rapid growth in the modernization of these technologies coming up, which has the consequence in the labor market that the new job profiles which are popping up, where the others become obsolete. So when you talk to economists, what the individual worker can or should do in order to keep up with these developments, many will say that further training is one of the keys in order to navigate this change in the work environment. At the backdrop, that the fact that there is skill requirements, which on the one hand change, such that you have new skills which were not imaginable 10 years ago. So 10 years ago, nobody knew what a prompt designer or prompt writer is. Now it's, I think, in everybody's mind what it really is. Whereas other tasks which can be automated more easily will disappear. And in such a situation, in order to secure prosperity for the whole economy, but also to secure job security for individuals and professional success, workforce training is one of the key ingredients. If you look now at what share of individuals participate in workforce training, the situation in Germany is quite mixed. So if you look at Eurostat data, and when you ask people, did they participate in on-the-job training activities in the last 4 weeks, about 8% would say they did. If you ask for the last year, it's about 30% who have participated in workforce training. What is concerning is that what we see when we differentiate between low and high skilled individuals who are and look at their training participation, we usually see that those who have already high skills, they invest in training, whereas those who have low skills, where you can imagine that they will be substituted at some point, do much less so. And so the big question is, why do we have a situation where especially those who are in need of updating their skills, of getting new skills to navigate the new labor market realities with AI, digitization, and so forth? Why do they underinvest in skill development on the job? And so we came up with a hypothesis, which now comes from my behavioral behavioral economics focus on research. Namely, we thought it might be the case that people just have a lot of uncertainty about how exposed they are to possible change on the labor market. And this is what we want to study here empirically. So what we will do is we will investigate whether people are misinformed about the automatability of their occupations, to be defined a bit later, and also to see what happens when you inform people about the correct extent to which their jobs can be, or their occupations can be automated. So do they change their planned participation in training, and do they change their labor market concerns? This is the idea of this project. So what do we do? What are the main questions that we're answering here? We investigate first whether people are aware of their own occupation's automation potential. So we will look at a sample of the adult population, 18 years plus in Germany. And the first question we want to ask is whether they know how likely it is that they will be a part of their tasks in their occupations will be or can be automated. The second question that we asked, that we want to answer, is now an experimental one, namely whether informing about the real extent of occupations automation potential affects people's labor market expectations and also the likelihood to engage in training. So what we did, so how we approached this project was we conducted a survey experiment in a large online sample where we randomly informed, this is the experimental part now, people about their occupations automation potential. So the data that we use comes from the E4 Education Survey, which is a large-scale survey, an annual survey that surveys the German population about education topics. The data which I use here comes from the 2022 wave. It's important to mention here that this data was collected before ChatGPT was rolled out at scale. So when we look at the results afterwards, keep in mind that this is not focusing on the latest developments of generative AI adoption, but it's the era before that, if you will. And so people conducted an online survey which took about 16 minutes, and the sample which we have is about 3,000 people in our sample who are employed, who are working in employment, and they're the ones which we focus on here in our study. That's the one part of the data. The second part of the data comes from the IAB. We already heard it in Christina's previous talks. And the Institute for Employment Research, the IAB in Nuremberg in Germany, they have a very interesting tool which is called the Jobfuturomat, which estimates the share of skills which can be automated within a given occupation. I'll give you an example of what this means and also of what our information treatment for those who were in the experimental treatment group looked like. So what you see here is information which we provided to people who have the specific occupation of being office clerks. And the information reads as follows in a specific example here. According to the study, we mean the IAB study here, 83% of core tasks in the occupation are automated, but can be automated. So this data, which is in the background here, the IAB data, estimates what core tasks can be in principle automated and done by machines. It does not say whether these tasks will really be automated in companies, because the ultimate decision to automate tasks or not to do that will be a calculation mostly done by companies who will find out whether or not it's lucrative to do so. But what we're looking at here is the potential that, given the technology that we have and given the tasks that people are completing in different occupations, X% of the tasks that can be automated. In the case of the office clerk, it would be 83%. For instance, writing standard emails would be one task which could be automated, which is now done by office clerks in person still. So what do we have? We in our experimental setup in the survey, we randomize people between two groups, a control group and a treatment group. Before we do any randomization or any information provision, we ask everybody about their current occupation, and also let them guess what the share of automatable tasks in their occupation is, from 0 to 100%. Afterwards, we randomize people into a control group and a treatment group. They answer the same outcome questions in the end, but the important difference is that the treatment group receives information about the automatability of respondents' specific individual occupation, whereas the control group does not. And by comparing answers to outcome questions between a treatment and control group, we can say the causal effect of providing information about the automatability of occupations is this and that. So the outcomes that I want to focus on in this talk specifically is the expected automatability of own jobs. So when we provide information, do people update their beliefs how what share of tasks can be automated? We also will look at labor market expectations, especially whether people are expecting changes in their everyday work environment and whether people are concerned about their future jobs. And we also will look at training participations. Do people plan to participate in further training, either to update skills they use for their current occupation or to participate in retraining activities which would equip them with skills used in other occupations, so whether they want to switch occupations. So what we find here at baseline is an interesting pattern, I think. So what you see here is the question that we are answer to the question which we are posing before any information treatment was done. So we ask people, what do you think? What is the share of tasks within your occupation which can be automated? And as we also know the actual occupations of people, we can now contrast the beliefs about people about their occupation's automatability with the objective actual automatability as calculated by the IAB. So if there would be so what you see here in the graph, you see here the occupation's actual automatability going from 0 to 100%. So this office clerk, which we have seen before, will be somewhere here above 80%. And we also see the beliefs about the automatability of the occupation, which is the answer to the question, what do you think as a survey respondent, what share of your tasks can be automated? And so what you see here, what you would see here, if everybody would be perfectly informed about her automatability, would be that every point here, each point representing a different number of automatability, so that there's more than one occupation within each point here. If you would be perfectly informed, you would see that all points line up on a 45-degree degree line here, which is not the case. So what we see here is a much flatter development, which tells us many occupations, especially those who have a high automatability, they underestimate the extent to which their occupation can be automated, or the skills within the occupation can be automated, which is problematic because people might underestimate how likely it is that robots or generative AI will take over their jobs at some point, and before they know they are out of their job. This is problematic. And so what we do as a first step now, we want to investigate whether providing information about the factual automatability of people's occupations affects their beliefs about how their specific job is automatable. And what you see here now is the same graph as I've shown you before. The difference now is that we ask about the specific automatability of people's jobs, which might be different from the average in the occupation, which was done post-treatment. And so what you see here is the dark dots represent people who are in the control group. They have not been informed about the actual automatability, whereas the light blue dots are the ones which have received the information. What you can see here is that the light dots are much closer to the 45-degree line compared to the dark dots, which tells us that the information about the automatability of the occupations of people really has effects on what they think, how likely or how automatable that their specific job will be. So we don't find a perfect match here because you can imagine that if you are informed about an average for your occupation, there are different reasons why you might think, yeah, but in my job it's different. I'm not so automatable compared to the average in my occupation, but I still see this strong trend that this misinformation, which we have seen before, can be alleviated if you provide people with the relevant information. Next, I want to look at how this treatment information affects outcomes. The first outcomes which I would like to look at are labor market concerns. So we ask people a battery of questions where we try to get at whether people are concerned about their professional future. And what we see here is this first coefficient tells us that the treatment, so informing people about their occupations, automatability, really increases their concerns about the future. They're worried now that they will lose their job eventually. The effect is quite large. It's 10% of a standard deviation, which is sizable in our specific setting here. If we differentiate between people who have a high or low automatability of their own occupations, we see that this overall effect is really coming from those who have a high automatability because they underestimate their occupation's automatability at baseline, and upon being informed about the actual automatability, they really are more concerned about the future. The same is true when you look at the outcomes. The same pattern emerges looking at outcomes which capture beliefs about people, how strong their work environment will change. So we had some different questions in the background and provide an index here again, and we again see that the treatment, so providing information about automatability, increases people's belief that their work environment will change, and this effect is again stronger for people who are yeah, more likely to be automated at some point in their occupations. So the difference between high and low automatability occupation people is not statistically significant for this labor market change index. The last result which I would like to show you concerns my motivation, which I gave at the beginning, which was participation in further training and retraining. So we as economists believe it's extremely important to keep skills updated through on-the-job training. And so the question now is, when we provide information about occupations automatability, does this affect the stated likelihood that people will participate in further training activities in the company in the future? In a specific case, we elicited this probability on a scale from 0 to 100% and ask people how likely it is to participate in training activities within the next 2 years. We differentiate between two forms of training: further training, which we understand as keeping or updating skills in one's given occupation, and retraining, which we define, or which is defined here as training which is set to change people's skills so far that they can switch occupations. What we find is that the treatment significantly increases average likelihood of further training by about 2 percentage points, from a baseline of about 40% of people who say they will participate in a training activity within the next 2 years. Importantly, the treatment effect is only present among those who have a high automatability, which is good news because they are the ones who would train less otherwise. We also find significant and positive treatment effects for the likelihood to participate in retraining activities within the next 2 years. Again, with the pattern now a bit less pronounced, but still that especially those who are in high automatability occupations, they're the ones who react stronger in terms of their planned training participation. So I would like to wrap up now to keep some time for the discussion. What we see is that on average, respondents or people in general, it's a large sample, so I think we can draw some conclusions for the population in general here, the working age population. They on average underestimate their own occupation's automatability, and that's problematic from a welfare perspective, because people, when they have information frictions, may underinvest in their skills, in keeping their skills updated. We also do find that that information provision about the actual automatability has pronounced effects on people's beliefs about their own jobs automatability, but also on down the road outcomes like planned participation in training initiatives, and also concerns about the labor market in more general. Beyond this specific paper, I think we can draw one important conclusion, which comes from the education economic literature, namely that information frictions are a prevalent feature in many parts of the education sector, also in the also in the on-the-job training sectors I have shown you here. So I think when we think of policies here, I think one very good strategy would be to think of information packages which you might provide to at-risk people in order to change their beliefs about the automatability and to bring them to the skills they require in order to be successful in the future labor markets. I think we'll stop here and thank you very much for your attention.
Thank you to Philip for a fascinating talk. As much as I said, thank you for a fascinating talk to Christina. Going on, that it's obvious that the element of information about future developments is very important. In a recent study about the online population in Germany, we found out that about 80% of the people asked this summer could say, "Oh, I know what AI is about, and I do know I can even explain it." But very obviously, even 2 years back, the outcome of these changes and the outcome of these changes on your individual skill level, on your individual level of retraining, is yet another issue. So my question is, information friction sounds nice as an abstract term. I don't know what the future will bring. Do we have data how often this Futuromat is actually being used and whether it's part of the skills in the apprenticeship system that you need to learn about how your occupation develops over time? So first question to Philip, another policy measure about saying that could be changed, or is it more a general willingness to be able to retrain and taking further continuing education?
That's a very interesting question, I think. I was talking to the president of the IAB lately, Bert Witzenberg, and he also was very interested whether their product is used by people who inform themselves. So I think what we can say now by revealed data, people don't know much about their own jobs automatability. And so I think only when looking at our data, if people would notice the tool and would use it, they would be much better informed compared to what they are now. So I think there is so what is nice about these information interventions when they work, they could be very cheap and very easily rolled out if you just make people aware that there is this tool. People usually find this interesting and they want to see how likely their occupation is automated. And this would be the hope that you don't need to create something new, something expensive, but rather provide information about what is already there.
Luckily, in the chat, there's one question popped up that I had expected and was, thank you, Oliver, for putting the question. How accurate are these estimates when nothing is more difficult to predict than the future? And if it's about the automatability, many aspects fill in. So the question is, of course, it's for the economist easy to use such a nice measure because it has been produced by other people. And IRB for the Germans is usually decently believable. But how has this been validated, whether that really is a decent prediction?
That's of course the future has uncertainty, and I want to stress that, and also the IIB is stressing that this data or the data they are providing is not predicting how likely it is that jobs are actually or tasks actually automated, but what their potential is, and the potential then depends on whether the potential is there. It depends on other factors whether this is being used. The IAB makes a lot of, so I think it's best measure of this kind that we have in Germany. To start out with that, they use about 4,000 occupations and have expert assessments of each task within each occupation. So very accurate. But are of course limits to it. So the IAB makes there are a few papers which are validating these measures, but of course there is some uncertainty with that. Having said that, I think it's the best measure which we have, and it is. If you look at concrete examples, I think it's quite intuitive what you see. university professors like we are, they're not automatable because teaching and research is hard to automate still. Don't know whether
I tend to disagree. I tend to disagree.
yeah, I think it changed after 2022 when ChatGPT came around the
Yeah,
corner. This is a big difference, but at least the old data is more reassuring for me. But other jobs which you can imagine that are automatable, they are also the ones which pop up at the highest, like office clerks, for instance. You can imagine a lot of stuff
yeah.
which is going on there.
If I look at the term automobility, it doesn't mean that it will be automated because there are so many influencing factors like productivity changes, investment cost. But one thing I'd like to come back is the issue of time lag. Christina already mentioned time lags between the descriptions of the skills needed for a specific profession and is very slow to actually change them. Um, and you mentioned, oh, this was done in 2022 when Gen AI and similar things weren't really at their full acceptance yet. Um, so what can we talk about the investment perceptions of skills in both areas? I think for young apprenticeships or people that do their apprenticeships are typically relatively young. It's a very long perspective to find out which skill might be useful in the future. And how would your results change if you look
Mhm.
at the actual present Gen AI discussion?
Mhm. So, Christina, do you want to go first? Go first, or should I go first? I'm happy with both options.
Yeah, you can start if you want.
And then we
Um,
give the closing word
mm,
to Christina, right?
yeah, perfect. So my take on this is I think there is has been mentioned. This is very important. A big time. So there's an inconsistency between academic research as we do it and what is going on in the labor markets. So we use data as the most updated data which we had back then is many years old, and so I think there is certainly limits to how we can extrapolate from our specific examples from the automatability of occupations from 2022 to now. This is, I think, where I would agree on because we weren't even aware of ChatGPT back then, and now I think 30 or 40% of people in the US are using it on a regular basis. So it's a big, huge penetration, very fast. But I think what sticks, and I think what is the important takeaway beyond the specific context here, is that awareness of training participation is a key to success in the labor market. Because one thing which does not change across different eras of technological progress was that it was always important for people to update their skills and to make them complementary to the new technologies and not substitutes. I think this is the overarching theme, which is quite independent of what specific technology we look at. Personal computers, the internet, or now artificial intelligence. Christina, do you want to add your perspective to this?
Yes, so in theory, I agree, and I think you also yeah, responded to one question that was in the chat about skills that are like underseen nowadays. So you mentioned the complementary skills that are really valuable, the skills that are complementary to new technologies. And what I would like to add is that, of course, we're always talking about the future of work, but how economists are approaching it is we try to learn from past developments. So this is also like one reason to draw on, yeah, these data sources that are unfortunately only available with a time lag. But here, there's also progress. So, for example, new data sources are emerging, like job postings data that are available almost in real time, and that also helps us to really track skill developments, yeah, in real time. It's hard to predict because no one expected, for example, ChatGPT to have such an impact in November 2022. So these things are unforeseeable, and so it's also really hard to train to these things, but we have to stay adaptable in case something like that comes up. So we have to make sure that the modernizations don't take as long as they unfortunately take now. And yeah, in case of the apprenticeship system, I think, or what we have seen is that, for example, they don't choose an apprenticeship based on has it been updated in the last 5 years. They choose
Yeah.
it in a sense of like, do I think this occupation is interesting? And to be honest, they also choose it based on what their parents might have in mind for them. So there's also research showing that parents also do a lot of the on-the-job research, like for their children. Yeah. So these are all factors that are in play.
It is my very unfortunate task that I have to watch the time. And for all of those that have been with us, I hope you had an interesting time to learn about these things. To our two presenters, to Philip and Christina, a lot of thanks for really showing in such detailed way how we can look at the issues that we said. And also, thanks for your last word. The all best practice is always best past practice. And if there are new general purpose technologies coming along, and the Gen AI was mentioned, the PC was mentioned, the internet was mentioned, mobile was mentioned, there might things that change. But I also thank you for putting your finger right on the meta skills of being adaptive and curious to learn new stuff, because it seems like that these elements of curiosity and creativity might be enduring meta skills. And then look forward to the next discussions with both of you about the next research you're doing. Thanks for all the participants. I hope you found it time well spent, and to our presenters, time well talked, and it was fun listening to you. And thanks to our organizers. And with that, thanks a lot. Bye bye.